In class 12th, today I am starting a new chapter, the electric circuit. This is our chapter number 6. And in this chapter you will study about the KIRCHHOFF'S law, Wheatstone bridge, potentiometer, and also the applications of Wheatstone bridge and the applications of potentiometer. So this is a very important chapter from the point of view of the numericals also. They are asked on the basis of the KIRCHHOFF'S law, on the basis of Wheatstone bridge, on the basis of potentiometer. So there are a number of questions based on in this chapter. So you have to study this chapter completely right from the beginning to the end of this chapter. So now first I am taking the KIRCHHOFF'S law. KIRCHHOFF'S law. Now KIRCHHOFF gave the two laws which after him are called the KIRCHHOFF'S law. The first law, KIRCHHOFF'S first law. He gave two laws. Now first law, this first law is also called KIRCHHOFF'S current law. In short, KCL or KIRCHHOFF'S junction law. KIRCHHOFF'S junction law. These are other two names which are given to this first law. This it is based on law of conservation of charge. This is the fundamental law which is followed by this KIRCHHOFF'S first law, and we know that in an isolated system the charge always remains constant. This is the conservation law of charge. Here suppose we have this point and there are some currents which are coming towards this one, I1, this is now your I2, this is now I3, and the current going away from this one like this one. This is now your suppose I5. This is now point O. O is called the junction point. Junction. This is a very prominent word used in railway. Have you heard the name of this junction? Railway junction. So in railway junction, what happens that number of trains coming from different direction meet at the point and then they go away from the junction. So similarly here, you know that New Delhi is the capital of our country. So all the trains coming towards New Delhi are called the up trains, and they are taken to be positive. And the train going away from New Delhi, they are called the down train. They are taken to be negative. So positive means coming towards the junction, and negative means going away from the junction. So here also we are having the currents. The currents are coming towards the junction point, and then they are going away from the junction point. Then this conservation of charge, this is how to apply it, because when there was no current, the point was having no charge. Then definitely when the currents are coming and going, then the total charge which is coming towards the junction point must be equal to the charge that is going away from the junction. So the sum of the charge is again equal to 0. So this is what that we have to follow. This law follows the law of conservation of charge. It states that algebraic sum of currents at junction point is zero. Algebraic sum of currents at junction point is 0. So mathematically summation I is equal to 0. This is what the mathematical formula of this law. The currents coming towards junction point are taken positive, and those currents going away from junction point are taking negative. So what we have, according to this law, here we are having this I1 plus I2 plus I3 plus minus I4 plus minus I5. This is equal to 0. Algebraic sum means that you have to consider the sign also. If current is negative, then you take it negative. If positive, then take it positive. We have to find the algebraic sum. Algebraic sum. Algebraic sum. This is not what. So that we have this I1 plus I2 plus I3 and this minus I4 minus I5. This is equal to 0. Or we can have that is I1 plus I2 plus I3 equal to I4 plus I5. So sum of currents coming towards the junction equal to sum of the currents going away from the junction. So sum of currents coming towards junction is equal to sum of currents going away from junction. So this is what the meaning of this one that we are having. This is called the first law given by the Kirchhoff. Now then we are having the second law. Kirchhoff's second law. Now this second law is also called, it is also known as Kirchhoff's voltage law. Shortly KVL, Kirchhoff's voltage law, or Kirchhoff's loop law. So this law is for the circuit which is closed, and then we have to take, so because of that this is called the loop law, and this is also based on the voltage. So this law follows the law of conservation of energy. It follows the law of conservation of energy. We know that the energy can neither be created nor destroyed, but it can be transformed from one form to another form. So this is what the law of conservation of total energy is always conserved. So here we have to take the electrical energy. This voltage, that is the measure of the electrical energy. So this law states now this has two statements, both I will tell you. It states that algebraic sum of voltage drop in a closed loop is 0. So what we have mathematically, this is now summation k equal to 1 to n. This vk, this is equal to 0. This is what the meaning of this one. This is the one statement. There is another statement. Another statement. This is what? The algebraic sum of potential drop at different resistances is equal to the algebraic sum of EMFs of different cells in closed loop. The algebraic sum of potential drop at different resistances is equal to the algebraic sum of EMFs of different cells in the closed loop. This is also here. So how to write to this one, that we can mathematically summation k equal to 1 to n. Ek is what? The algebraic sum of the EMFs of different cells in the closed cell. This is equal to algebraic sum of potential drop at different resistances IR. This is equal to so much. Here the value of this I1, this I, they are not to be same or the equal. I1, R1, I2, R2. They may be different to this one also. So we have not taken the value of K like to this one. So this is also given like this, or you can say it to be like this one. You say either way, like this or like this. This is the same one. Now let us take an example. It is better to understand. Let this is a resistance R1. This is a cell. This is resistance, and then we are having this is another resistance. having a like this. Now let this positive negative, this is now positive negative. Its EMF is suppose E1, this is now your E2. It is giving the current I1, this is giving the current I2. This is your R2, this is now resistance your R3. Here the current flows, that is equal to I3. And then here this is now I2 and here this is now your I1. I have taken this. Now then we have to choose the direction of the current as we want. Now this may be clockwise or anti-clockwise. So this is better to choose the direction of current as given in this loop. That is better. You have not to take, if suppose the currents are given to be clockwise, then you take anti-clockwise. This is maybe wrong one. Like this we have shown the current, this is now clockwise. Here we are showing that this is now anti-clockwise. So you take this clockwise and this you take the anti-clockwise. That is no meaning. This is our selection, that how we have to take it. So now let here this we take like this. This is now loop number 1. Now then we take this to be like this one. This is now loop number 2. Then there is one more loop, that is the outside one. Outside. So let this now moves like this. This is now loop number 3. So we have the 3 loops are there. Suppose this is the point A and this is now point B. So now what we have, that we have taken this direction. It means that the potential drop across in this direction will be taken to be positive and opposite to this one, this is taken to be negative. And whatever we says to be positive and negative, when the current enters at negative and goes away from the positive of the cell, then EMF is taken to be positive. If the current enters from positive and goes away from the negative, then this is taken to be negative. So here we can say, now loop 1 or loop 1. Loop 1 is this one. So loop 1 is that how to find, this is now your I1 R1, I1 R1. Then this we have this plus this is now your I3 into R3. This is equal to, now current is going like this from negative to positive. So E1 is taken to be positive. This is now equal to E1. This is now equation number 1. Similarly for loop 2. Loop 2. This we have taken like this one. So this I2 and I3 are positive. So we will have this I2 R2 plus I3 R3. This is equal to, now current is going like this from negative to positive. So this E2 is positive. This is equal to E2. This is now number 2. And then we are taking the third loop, that is outside resistances for loop 3. For loop 3. When we are going like this, the current will be taken to be positive and opposite to this, that will be taken negative. So what we have, this I1 is in this direction. So we have I1 R1. Now this current is opposite to this direction. So I2 is negative minus I2 into R2. I2 into R2. Now then we are coming here. This resistance will not be taken because we are taking the outside only. And this is equal to what we have. Now in this way, this E1 is positive. and E2 is negative because this is current is opposite to this one. This current I2 is opposite to this direction. So what we have? This is now your E1 minus E2. This is now number 3. Thus there are 3 equations. And now one more what we have, that at this point A, I1 plus I2 is equal to I3. At point A, I1 plus I2 is equal to I3. This is now your 4. So make use of these equations and then simplify and find out the unknown currents or the unknown resistances which are given to this one. So this you remember that the current which is flowing in the circuit is in the preferred direction. Then this is taken to be positive. If you are opposite to that, then this is negative. And in case of the cells, when the current enters at the negative terminal and away from the positive terminal, then this is taken EMF taken positive. And if the current is from positive to negative, then this is taken to be now negative. So this is what that we have the meaning here. This summation EK equal to summation IR. So you can see here that these resistances are not the equal. You can see this I1 R1, I3 R3, I2 R2, I3 R3. This may be different or this may be the same one also. Okay. Now you can see that in place of I3 we will use I1 plus I2. I1 plus I2. Then R3 will come out to be along with this I1 and I2. So that will be different one. So in this way we can make use of these laws to find the current in some of the resistances which are given in the closed loop. So these are the 2 laws given by Kirchhoff. So first law is based on the conservation of charge and second law is based on the conservation of energy. Conservation of energy. So you state in either. This is the Kirchhoff's law. Thank you very much.